And this is the region that on the ground that we're going to be integrating upwards to do the double integral. So the double integral of whatever the region D is, and you rearrange this guy, and if you rearrange him, I think in this particular question, you get that guy, right? So that would be the generic setup. Do you recognize a question like that? In which case I can move on to the next one. If not, I'll start with that one. Does that look new to you?
I just checked my notes and I don't see a problem like that.
Okay, then we will do that one first. So what you need to do is basically you have to find the limits of integration. And that's going to be based on this information here. So there's typically going to be a region bounded by two curves, or a line and a curve perhaps. So if I go straight into the sketch of it, that's what y equals x squared looks like. If you draw x equals y squared, can you trust me, it looks like that. So it's pretty clear in my mind that the region we are talking about is this one. Now I can describe this region in terms of x's, I can describe this region in terms of y's, which is totally fine because both will work. In this particular example, both will work. But since I just like x's, I'm going to do the vertical version. So basically, x is going to go from 0 to here, right? Can I say that point is 1 because it's pretty obvious it is 1? But if you needed to, when you solve, when do these intersect? Since I am going to be doing this particular rectangle, the y values are going to go from here to here. And the y values are going to be top, take away bottom. This top function is really not the order I need. Don't have to convert it into square root of x. So this region, top guy first, is going to be y equals square root of x. And on the bottom, x squared. And the x's are going to be going from 0 to 1. And since I'm doing the y's first, you go dy dx. Are you comfortable about how I set up that particular integral? Would you also agree that this is pretty standard power rules and x to the halves kind of thing? And so I'm going to risk a dot, 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 and hopefully you're comfortable with that. We're looking good? Okay, this is question 9. I've kind of already started the question, so I'll tell you what you're doing. You're taking a function z equals 3xy, and the region wasn't described as this triangle. The region was described by telling you the coordinates of this triangle. So I've actually drawn the picture, but in the question, it would say from 1, 1 to 1, 4 to 1, 2, and you draw the picture, right? You may well get a different version in your own homework question. So these are like question 9s, not necessarily the same question 9 that you're looking at. Right, in this particular question, I'm going to do the vertical line. Whenever you do the vertical line, everything ends up being x's, right, essentially. So I am going to do y equals somebody to somebody, and the x is going from 1 to 4. That's the 3xy bit. The only bit that's really missing is that guy, because this guy here is y equals 1, right? This line here is y equals 1. This guy up here, well, isn't that the equation of the line that makes that slope? You agree? The equation of the line that makes that slope. So this is the only time I think in this homework that you actually do that. But I do need to know the equation of the line joining the point 1, 2 to the point 4, 1. So help me out here. How do you find the equation of a line that joins 2 points? Because that's probably something you've not done in a long time. Well, I guess you could just say I can't do the question and move on, but hopefully that's not your attitude.
Minus x1 over y2 minus y1.
That way around? And you've just told me how to find the slope of that line, so that's a good start. But it's y's over x's. I think you might have said x's over y's, or maybe I just misheard you.
No, I said it wrong.
But you recognise this is the right way. Does it come to you now?
Yes.
Okay, so here we go. This guy's called x1, y1. This guy's going to be called x2, y2. So it's going to be 1 take away 2 over 4 take away 1, which makes perfect sense. Doesn't that line have a negative slope? Actually, if I thought about it, and you did it in square paper, couldn't you just count boxes and do rise over run and get the slope that way? I mean, it would have worked. Now, we need another formula to get the equation of the line. We know the slope. Good start. We need to finish it now.
Y equals mx plus b.
That'll work. The other one?
The point slope form.
Yeah. Now, I don't mind y equals mx plus c. If you want to do that, don't you plug in this and pick a point and solve for this, the second missing variable, because you already know m. But in this case, you just plug in 2. I call them B and A. I should really. Is that the version that you're more comfortable with? It's the same formula.
Yeah.
So y take away this guy is negative 1/3. X take away this guy. So negative 1/3 plus 1/3 plus 2. So I hope I did this right. That should be the equation of that line. Well, the only reason I needed that is so I could say y goes from 1, which is the bottom, to the slope line, which is this fella. And that's the integral setup. Can I do a dot, dot, dot again? Because we have done quite a few of these. Aren't you just going to integrate with respect to y, then plug these two guys in, and then integrate with respect to x, and you're good to go. So okay to leave at that point, or do you need to say more? Last things, okay. This is a version of question 10. This straight line was actually described in the question like that. So we're being asked to take, in fact, that was the whole package. They described the region in terms of x being 0, y being 0, and x plus y being 4. So you created this triangle. The function that you're going to do it to is this fella. In this case here, you put that fella in there. Can you see it goes from 0 to 4 minus x? And that's really all the help I want to do in that. Not even sure I really needed to do 10, to be honest, now I think about it. So I'm skipping by that one really quick. And now we have a new puzzle. You're not going to find, I don't believe they even ask you to find it. Yeah, they just ask you to sketch it. Now, if you go to GeoBra, can't you type in z equals 8 minus x minus y? And I'm really bad at drawing this, but you end up not just with that triangle, but you end up with a plane where that triangle is part of it, right? And what you have got, so I'm going to have to show you what this question looks like, is really just pick a picture. So in a lot of ways, that's going to be a bit quicker. But I'm going to have to shrink these pictures down so we can kind of see them even in small version. Can you see that there's 4 guys? Now, I guess if you put it into GeoBra and you looked really carefully, you might be able to figure out who those guys, which one of those 4 fits. But what I'm going to do instead is I'm going to show you how we can figure out which one is the right picture. And the way I'm going to figure that out is I'm going to figure out what the bottom triangle would look like, and hopefully only one of these 4 pictures fits that. If I end up with only with 2 of them fitting it, then what I'll do as my backup is I'll find out what this place here is, and we're good to go. Right. So that's kind of my strategy. Let's kind of show you how you put it into action. Now, in this case here, the integral from 0 to 8 take away x and the dy, that tells me that this fella here is y equals 8 minus x, and this guy here is y equals 0. So, can you imagine your little xy axis thing? This line is 8 minus x, and this line is 0. So, basically, aren't you looking at that guy? And you're going from 0 to 8 in the x's. Well, as I look through the pictures, you have to orientate it a little bit funny, because in the 3D world, the picture looks like that. So basically, don't I want a picture where the bottom triangle looks like that? And so as I scan through them, only picture 2 and picture 3 have that feature. The other 2, these are 1s, right? So I got a restriction now. I know it's only picture 2 or picture 4, right? Picture 2, picture 4. Now, the function is z equals 8 take away x take away y. At the origin, x and y are both 0, so that makes z 8. So can you imagine I want an 8 up here? And so I look at the picture and I find out it's the 4th dot. And that's how all of that work was, really just to pick what does it look like. Do you have any questions about what I did there, although I know I went through it quick? Okay, things are good. Next question is basically connected to that. I think I've missed something out here. Oh, no, it's here. They want us to sketch this region. And once we get our picture, there's 4 pictures in the homework and you pick the right one. So when you look at this guy here matched with these 2 guys here, aren't they basically saying x equals 0 and x equals y? Now, if I rewrite that in the way that my brain works, isn't that the same thing as saying y equals x? So it means it's that line. Now, when you say x equals 0, what line or axis is x equals 0?
The
The
y
x-axis?
Oh, I have both answers here. Y equals 0. If you do all the points whose, sorry, x equals 0, my apologies. If you do all the points whose x coordinate is 0, don't you get the y-axis, which is correct. Now, if you go to this fella, isn't this guy just saying y equals 0 to y equals 4? So can you see y equals 0 to y equals 4 represents that triangle? And then you go looking for whichever one it happens to fit and pick that picture. Now you might think, why do we want to do this? I mean, is there a use for it? And there is. It's coming up, not quite there yet. I think the one after this, you'll get to see why being able to draw the region can help you find an integral. Right, let's look at this one now. Would you agree that because this is dy, that makes y equals 0 and y equals log x. Now, if you do the log function, y equals log x, it looks like that. Great. If you do y equals 0, what axis is y equals 0?
The x-axis.
Right, so I'm only interested in this bit, right? Now, x equals 1 to x equals 2. Do you know x equals 1 here and x equals 2 is here? Do you see when you put the whole package together, you now have your shape? That shape is D. We okay? Now, if you happen to get a question where it's x equals log y and x equals 0, you can imagine one where these were x's, couldn't you stick it into GeoGebra or Desmos, whatever, and see what it looks like? Probably use Desmos myself. Now, we are going to find this integral, and they tell you in the homework, by reversing the order of integration. What they're going to, the way you're going to do that one is, step 1, is you're going to draw a sketch of the region. Now, oops, I forgot a letter in the alphabet here. There we go. Because this says dx, and you see this guy here, right? Dx and this guy here, would you agree that we're looking at x equals 6 and x equals 3y? Now, if I rearrange that one, isn't it a little bit easier to think of it as 1/3 x, just for drawing purposes? So I'm going to draw a picture, and I'm going to draw a line, and I'm going to call it 1/3 x. It originally was called x equals 3y, but it's the same thing, right? And the other guy was, the other guy was x equals 6. Now, where the heck is x equals 6? Vertical line, horizontal line?
It's a vertical line.
Right, so somewhere about here, right? Now, this guy says, well, y equals 0. Great. Now, y equals 0 would be here. And then y equals 2. Well, heckin' 2. Y equals 2. Oh, if y equals 2, x equals 6, so y equals 2 would actually be here. So I'm taking this straight line from 0 to 2. Let's put that number in. So that is a region. 0 to 2 with a straight line. So far, so good. Now, reversing the order of integration means that we want to take this same guy, that's 2e to the x squared, but we want to do the y's and the x's. So I'm going to describe this region in terms of x's. So I'll draw my little vertical line. In this story then, doesn't x go from 0 to 6? And won't y go from here to here? Now that makes y equal 1/3 x, and you finish at y equals 2. So this integral is equivalent to this one. All we've done is reverse the order of integration. It's much easier to do when it's a rectangle, because see, when it's a rectangle, don't you just switch the numbers and you're good? But can you see, you can't just switch these two integrals around, because if you did that, wouldn't you have a 3y and a 6 on the outside, and that's never going to be good. You're never going to get a number out of it. So it's a little bit more complicated. You take that region, you figure out what it looks like, and then you reconfigure it in terms of doing the x's before the y's or do the y's before the x's, whichever way around you've been asked to do it. Why do you think they even asked us to do it? Now look at that. How do you integrate 2e to the x squared? And the answer is you can't. There is no antiderivative of e to the x squared. I know what e to the x is, but I don't know what e to the x squared is. And there's not a u sub in the world that's going to help me either, or an integration by parts. Now, if you switch the order on this, let's take it a little bit further. So I'll focus on this guy. It's going to be the integral from 0 to 6. Well, if you do an integration of this with respect to y, don't you just get 2y e to the x squared? Evaluated at y is 1/3 x to y equals 2. Did I say y there? I did. I'm a little bit puzzled. This is great, this is bad. 0 to 2, 0 to 2, 0 to 6, straight line, 0 to 6, 0 to 2, straight line. That's what I did wrong. I shaded the wrong side. Easy fix. That guy goes there, and this is 0. Right. So it's not from that line to that line, it's from there to there. Right. So plug in 1/3. I get 2 times 1/3 x e to the x squared. Take away nothing. That becomes 2/3 x e to the x squared dx. The reason I knew that I'd done the other one wrong is that if you plug a number in here, you end up having to integrate like 2/3 e to the x squared, which is also impossible. But do you see this is doable? And the reason this is integratable is because of that x. What method will you use to integrate this to get the final answer then?
U sub.
And x squared, and you're good to go. So we can't integrate e to the x squared, which is why we had to rearrange the order of integration so that we could eventually get to this place that is doable. And well, I had a 50-50 chance of shading the right half of the shape, and I ended up shading the wrong one. So I guess the moral of that story is be careful. Okay, let's look at this fella. Same basic question. This is an x, so this is x equals 4 to x equals cube root. Let's see if I can get this one drawn correctly. X equals 4 is basically here, and x equals the cube root of y is just another way of saying y equals x cubed, so it looks something like that. And then this fella says y goes from 0 and what, 16? That number doesn't look right. Wonder if I wrote the numbers wrong. Oh, there we go. I did. 0 to 64, which perfectly matches that guy there. And so we are looking at that fella. Isn't 4 cubed 64? So I know it matches. Okay, you want to switch the order of integration. Right now, it's x in function of y. Let's do the other way around. Let's do this fella. So we're going to do the integral, a typical value then would be from y equals 0 to y equals x cubed. And then the x's would go from 0 to 4. And the function that we're doing it to is 3x to the 4, do the y's, do the x's. So that was the, yeah, that's correct. That was the original integral. This is what happened when you switch the order. Let's take this one extra line and then I'll finish.
Wouldn't there need to be an e in that equation?
There is. There it goes. With respect to y, you're going to get 3y e to the power of x4, evaluated at 0, evaluated at x cubed. If you replace the y with x cubed, take away nothing, so that's what you get. Do you see that you now have an integral that you can do with a u sub? And the u sub would be x to the 4. Did we do average value of a function yet? Did we do it yesterday?
Yes.
I think so.
Right, so I'll just show you the two questions that they have, and if that works out fine, we're pretty much good to go. The general formula for getting the average value of a function is 1 over the area of the region D, followed by your usual volume formula. So if you were going to do, let's show you the two guys. The two fellas that you're going to do on your homework look like this. Find the average value of the function 3xy, and the region D is described in the form of a triangle. And then the other one is find the average value of 4x sine y, and they describe region D in the terms of this fella here, right? So I think I'll do 17. So the function that we're going to find the average value for is 4x sine y. The region D is described by y equals 0, y equals x squared, and x equals 6. So I'll go to the white screen and work on that. From this information here, I should be able to draw it. Y equals x squared. Y equals 0 is this guy, and x equals 6 is this guy. So are we comfortable that that is region D and where I got it? Now, I need to know the area of D, which means I'm going to have to go back to my Calc 2 roots. Isn't the area of D the area of that single integral from 0 to 6? And that happens to be 1/3 x cubed, evaluated at 0 and at 6. Oh, yeah. 6, 6, 6, that's going to get you 9, and 2, 2, 2 is going to get you 8. So I'm going for 72, and you can tell me later if I did it right. So the average value of the function is going to be 1 over 72 of the double integral of this region, like that. Just out of curiosity, if somebody's got a few seconds, check that out for me. So it's going to be 1 over 72. Now, let's look at double integral of 4x sine y. Right, so double integral of 4x sine y. Well, I'm looking at this integral and I have two directions to go. Can't I do my usual typical, because I like verticals and x's, and do it that way? So I'm going to set it up that way. And if it works, great, I got the answer. But I have a backup plan. Can you imagine the math just gets really ugly if I go this way? Can't I always go that way and change it? Right? Maybe if I go that way, the math is going to look easier. If I get the answer, then I don't care. If I get into ugly answer, it's not going to work, then I just stop and I try the other direction. Now, for this fella here then, won't you be going from y equals 0 to y equals x squared? And won't x go from 0 to 6? Are you happy about how that guy becomes these integrals? Right? Nothing to the curve. X goes from 0 to 6. Boom. The order that I'm doing it then, isn't it? It's y before x's. So I'm now going to have to move this because I need the room. I'm now going to look at this guy here. And let's see what we get. If you take the integral from y equals 0 to x squared of 4x sine y, and you integrate it with respect to y, okay, integrate this with respect to y, looks like you're going to get negative 4x cosine y. Are you happy about where the negative came from? Because integrating a sine gets you a negative cosine. And that's going to be evaluated at 0 and at x squared. Plug in the guys and let's see what we get. Negative 4x, the cosine of x squared, take away essentially negative 4x times the cosine of 0, which is 1. So I end up with negative 4x cosine of x squared, add 4x. Okay. Now, you're then going to integrate from 0 to 6 with respect to x. And I just look at this point and I say, is it doable? And if it is, then do it. And if it's, nah, I don't know how you integrate that, that's some weird looking function, you've probably went the wrong direction in your setup of the order of integration. In which case, just change it. Just go that way. One of them has to work or the question's not fair, right? So if A doesn't work, then B is. I'm going to leave this one. Would you agree that guy there is just 2x squared? Calc 2 world, how are you going to integrate the first piece?
U sub
U sub. And the U sub's going to be
x squared.
x squared, right? Nothing too scary, right? I can imagine a different world. I haven't seen it yet, but can you imagine this was 4x cosine x? That does make a difference, because then won't it be integration by parts? I mean, that's, well, what are the rules? It could be a power rule. It could be a standard integral. It's a U sub, or it's an integration by parts. You know you've only got a limited choice of techniques. It has to be one of them or the question's not fair. Are we good? Right. So that allows me to give you a little taster of what's going to happen on Tuesday. We're going to do double integrals using polar coordinates. If you want to find a double integral over some region D, but your function is given in terms of x's and y's, like it's x squared plus y squared or 2 sine x or something, right? dx dy. You can Basically, it's like a change in variable, and you can do it in terms of polar coordinates. So what does that look like? Well, if you're wondering, isn't x r cos theta? Won't y be r sin theta? And that's not a mistake. Do you notice that it's not dr d theta? It's r dr d theta, and that's just that's just what needs to be done. It comes about from a thing called a Jacobian, which you'll actually learn about later, and so you'll actually find out later why that works. But right now, you are just going to remember that the dx dy gets replaced by that guy. Some integrations are just much easier to do if you convert the information into polar coordinate form and integrate the double integral in that format. So I want you to imagine that I want to do a double integral d of e to the power of x squared plus y squared and dx dy. And I tell you that d is an entire circle. This particular circle is x squared plus y squared equals 9. Now, if you try to do it with the method that we've just finished doing, wouldn't you probably have to do a little rectangle going here? Wouldn't the top half of the curve be the positive square root of 9 minus x squared, and the bottom half of that curve would be some ridiculously ugly negative version of that? Can you imagine that it is never going to play well with this guy? You'd end up with an integral that was just not doable, right? Algebraically, you wouldn't be able to get the answer. So let's take that same question and convert it into polar. Well, the first thing you do is convert region D, which is what that is, into polar. Now, in this particular question, would you agree that what you're looking at is basically a circle whose radius is 3? Right, that's the outside. So if I wanted to describe this fella, couldn't I do from r equals 0 to r equals 3, and wouldn't that basically fill in the circle as far as r is concerned? Now, since this is a complete circle, won't theta start at 0 and finish at 2 pi? So if I wanted to describe all the points inside this disk, this circular disk, you would go r equals 0 to 3 and theta equals 0 to 2 pi. And then you'd go e, but instead of x squared plus y squared, you would replace it, right? And you would replace x squared plus y squared by its generic polar version. R dr d theta. Now, if I rewrite that again a little bit differently, but only tiny bit different. Would you agree that we can do this with a U sub? And then the last bit's easy. So let's, while I'm getting set up, say hi for attendance.
It's already done.
Well, everybody already did it? Are you lot getting independent of me? Are you lot growing up and leaving home? You don't need me to tell you stuff now? Okay. Suppose that's D. Set it up for me. Okay. Set it up for me now.
Theta is 0 to pi, and then r is 0 to square root of 10.
Is it square root of 10
No,
or
it's
10?
just 10. It's just 10.
And then who cares where that is? You can figure that out later. dr d theta. Don't know how well I'm selling this, but can you imagine there can be situations? It's a very niche market. Using polar coordinates is really only valuable or sensible when the region is, for want of a better word, circular or curved. Right? I wouldn't try and use polar coordinates with rectangular things. They're easy done the other way, right? I wouldn't use it with triangular things. But wouldn't you probably use it with bits of circles or halves of circles or whole circles? For the last one for today, set that region up.
Wouldn't that be theta from 0 to 2 pi and then radius from 3 to 5?
And it would be, yes. And if it was only the top half, wouldn't you just change that to 0 to 2 pi? Suppose it was the bottom half, because that could happen. Theta equals pi to 2 pi. Suppose it was the right-hand side. Oh, that's a bit sneaky. Negative pi upon 2 to positive pi upon 2. You see, in this situation, it makes more sense to use a negative answer. So bits of circles, things that are circular, curved, polar coordinates is your guy. I haven't said what this guy is, not that it matters. But guess what? Because at least in the examples I've done so far, aren't you allowed to switch the order of integration without doing anything special? Because if they're both numbers, switch places, don't matter. So I can imagine some situations where maybe you want to do the theta before you want to do the r. That makes sense that you could see a situation where that could happen. So you can set it up this way, but you might look at it and say, nah, let's switch places. Much better. We have learnt some cool stuff today.